Okay, we have equations with rational expressions, and one of the tips is to first notice, do any of the fractions have the same denominator? So this fraction and this fraction does. So the best idea that I recommend is get this entire fraction over to that side. Well, this says negative, so we're going to add this entire thing over here. So we're going to add x plus 1 over x squared plus 4x. All right, and let's see if that's what I did there first. Yep, so that's what I did. And now we're adding that. They all share the same fraction, so I can put that over the denominator like that. And then notice the denominator, these both share an x, so I'm going to rewrite that as x outside of parentheses and then x plus 4 on the inside. All right, so, and then in the numerator, we only have an x squared, but we have a negative 6x plus x, so that's going to be negative 5x, and then 8 plus 1 is 9. And then what I noticed, to get this fraction to have the same denominator, I just have to multiply it by x plus 4. Well, x plus 4 times 1 is just x plus 4. And here is the coolest thing. Once both sides of the equation, everything has the same denominator, whoops, you can, it's not that it goes away, you can just ignore it. The other important thing to note is that in the denominator, the x value could never equal 0 because that would cause the denominator to be 0, and x cannot equal negative 4 because that would cause the denominator to be 0. But those are our only two caveats, is that the x can't equal those two things. All right, so once we have the denominators equal, and we notice that on the right side it's a quadratic, so I'm going to subtract 4, subtract 4, subtract x, because I want the numerator now to be a quadratic that we can factor. So look at what I have. I have, let's see, negative 5x subtract x is negative 6x, 9 subtract 4 is 5. Factors, so factors of 5 that add up to negative 6. Well, that would be negative 5 and negative 1. They multiply to be positive 5. They add to be negative 6. So we're going to factor that, and then we can solve. So this x, the additive inverse of negative 5 is 5. The additive inverse of negative 1 is 1. And then you need to check your answer. And I'm not going to take the time to do that here because it's lengthy. But I did go ahead and double check. I put 1 into each of those x's, and then I went back and put 5 into each of those x's, and both of them worked. So those are our two answers, with the exception of, just so you know, we could never have x equal to those two things. So if for some reason algebraically we solved and x equaled 0 or x equaled negative 4, that would be a non-solution. All right, that's it for this one.